Blockchain is a type of digital record-keeping technology that allows information to be stored, shared, and verified across a network of computers without needing a central authority. Instead of relying on one organization to maintain the data, blockchain distributes the responsibility among many participants. This structure makes it highly transparent and resistant to tampering. Blockchain was originally created to support Bitcoin, but its uses have now expanded far beyond cryptocurrency. At its core, a blockchain is a chain of blocks, where each block contains a group of verified transactions or data entries. Once a block is filled, it is linked to the previous block using a unique cryptographic code called a hash. This linking creates a chronological and unchangeable chain of information. If anyone tries to alter a block, the hash changes, breaking the chain and alerting the entire network. This design ensures the integrity of the data stored on the blockchain. One of the defining features of blockchain technology is decentralization. Unlike traditional databases that are controlled by one server or company, blockchain is maintained by a distributed network of nodes, computers that follow the same rules. Each node stores a copy of the blockchain and participates in verifying new transactions. Because the same information exists across many machines, it becomes incredibly difficult for hackers or malicious actors to compromise the system. Transactions on a blockchain follow a clear process. A user initiates a transaction, it gets broadcast to the network, and nodes begin verifying it. Verification ensures the transaction follows the rules of the blockchain and that the data is valid. After a set of transactions is verified, they are gathered into a new block. The block must then be approved through a consensus mechanism before being added to the chain. Once added, the block becomes a permanent part of the blockchain and cannot be easily altered. Consensus mechanisms are essential for blockchain security. Different blockchains use different methods to achieve agreement among nodes. Bitcoin uses proof of work, where miners solve complex mathematical puzzles to validate blocks. Other blockchains use proof of stake, where validators lock up cryptocurrency to earn the right to add new blocks. These mechanisms ensure that the network operates fairly and is protected from manipulation, even without a central authority. Beyond cryptocurrency, blockchain has become valuable in many industries because of its transparency and reliability. For example, supply chain companies use blockchain to track products from the source to the customer, ensuring authenticity. In healthcare, blockchain can securely store medical records. Governments explore it for land registration, and businesses use it for secure voting, identity verification, and preventing fraud. Its ability to provide trust without intermediaries makes it suitable for a wide range of applications. Despite its benefits, blockchain technology faces several challenges. Scalability is one major issue. Blockchains can become slow and expensive when many people use them at once. Energy consumption is another concern, especially for proof-of-work systems like Bitcoin. Additionally, while data on a blockchain is secure, errors or false information entered into the chain are permanent. Regulatory and legal uncertainties also affect how businesses adopt blockchain technology. Even with these challenges, blockchain continues to evolve rapidly. Developers are working on solutions like Layer 2 technologies, sharding, and more efficient consensus methods to increase speed and reduce costs. As interest grows, governments, companies, and innovators continue exploring new ways to use blockchain to improve trust, efficiency, and transparency in digital systems. What began as the backbone of Bitcoin has now become one of the most influential technologies shaping the future of finance and digital infrastructure.